Today we see RSA algorithm. Okay, so first we see what is a RSA. Who found RSA? So RSA developed by Rivest, Shamir and Edelman of MIT in 1977. It is a generally published scheme. It is used for public scheme. Okay, public key scheme. Okay, so based on exponential in a finite field over an integer modulo of prime. So it is RSA use a large integer. Okay, example 1024 bits. So security due to cost of factoring large numbers. Okay, so here factorization is hard. So it takes O of E log n log n operations. RSA key setup. So here each user generate a public and private key pair. Okay, so what actually do? So selecting two larger prime at random. Okay, so P and Q, it is a prime number. Okay, so we select two large prime numbers. Okay, so compute their modules. Okay, so modules n is equal to P into Q. Okay, so we find 5n. So how we can find 5n? So P minus 1 Q minus 1. Okay, then we selecting a random encryption key E. So here condition is 1 less than E less than 5n. Okay, so we find those numbers that modulo is 1. So we actually here find is to GCD of number. Okay, so 5n you already 5n is already we find. Okay, so here we choose a number that mode is 1. So we apply 1 2 3 4 5 6 so on. So mode 1 we find a GCD of that number. Okay, then we solve the following equation to find the decryption key D. So how we can find the D? So E into D is equal to 1 mode of 5n, and condition is 0 less than equal to D less than equal to n. Okay, and last publish their public encryption key PU is equal to EN, and keep secret private decryption key PR is equal to DN. Okay, so this is a RSA algorithm, key generation, encryption and decryption. Okay, so first select PQ. Okay, so both are prime. Calculation n is equal to P into Q. Calculate 5n P minus 1 Q minus 1. Select integer E. Okay, we find a GCD of that number. Okay, and mode is 1 and condition is 1 less than E less than 5n. Calculate D. So D is equal to E raised to E mode of 5n. Okay, so then public and private key we find. Then encryption we find ciphertext C is equal to M raised to E mode n, and decryption plaintext is equal plaintext M is equal to C raised to D mode n. Okay, so key setup. One example of RSA algorithm. So here we choose P is equal to 17 and Q is equal to 11. Both are prime numbers. Okay, so computer n is equal to P into Q. So 17 into 11 is equal to 187. Okay, then third step is to compute 5n. So P minus 1 Q minus 1. Okay, so here P is 17. So 16 P minus 1 means 17 minus 1 60 and Q minus 1 11 minus 1 into 10. In 16 into 10 is equal to 160. Okay, so select GCD. So 5n is equal to 160. Okay, so we choose a number that mode is mode is equal to 1. Okay, so 1 in 1 to 6 here applying GCD is not 1. Okay, but in 7 here applying, so is mode is equal to 1. So select E is equal to 7 because the mode is 1 whenever we applying 7 here. Then fifth step is determine D. Okay, so how we can find D? So D E is equal to 1 mod 160, okay, and D less than 160 means D less than 5n, whatever 5n is there, okay. So here one equation to find D, so 5n star I plus 1 divided by E, okay. So 5n, so 160 into 1 plus 1 means 161 divided by E 7. So 161 divided by 7 is equal to 23. Here first round we got a decimal value, but this is not case for other examples, okay. Here first round we get a 23 decimal number, okay. So every example it is not possible. We can find here 1 2 3 4 5 6 up, okay. So up to we get applying until we have we got decimal value, okay. So after D, step 6 is publish public key PU, okay. So PU means E or public key, so public key E or N, okay. So here E is 7 and N is 187, so 7 or 187 is a pair of our public key. Then keep secret private key PR is equal to 23 and 187 means D and N, okay. So D is 23 and N is 187, so it is a private key, okay. Then RSA encryption and decryption. So example is given a message M is equal to 88, okay. So message is less than 5n, okay. So sorry n, okay. Then encryption is equal to C is equal to 88 raised to 7 mod 187. So in calculator, in scientific calculator we applying 88 raised to 7 mod 187, so we got 11, okay. And as well as decryption is M is equal to 11 raised to 23 mod 187. So after calculating the 11 raised to 23 mod 187, we got the answer 88 last, okay. So this is encryption and decryption. So guys, thank you.